This is the video for graphing logarithmic functions in DeltaMath. Let's go over the steps that we're going to need to use for graphing. The first step is to describe the translation. Then we're going to find the vertical asymptote. We'll identify the parent logarithm. We'll rewrite the parent log in exponential form. And as a quick reminder, when you have an equation written as y equals log base b of x, we will rewrite it, remember the loop-de-loop, b to the power of y equals x. And we'll do that together very shortly. You're going to create a table of values. You're going to graph the vertical asymptote. It'll be a dashed line. And then we're going to graph the logarithmic function by plotting two whole number points. So any fractions we get, we won't have to graph. Okay, let's jump right in and get started. Okay, let's look at the first problem that we have to graph. It's f of x equals 3 times log base 2 of x. So what is the translation that's occurring here? So this 3 out front means that we're going to have a vertical stretch by 3, all right? And then let's go ahead and look at the vertical asymptote. What is the vertical asymptote? We're not adding or subtracting anything from the log. So when you're not adding or subtracting anything, then that's going to be represented, nothing is represented by 0. So the vertical asymptote is simply x equals 0. All right. Now to actually create some coordinates, one of the things we need to look at is what is the parent function. So forget about the 3. Remember the parent function. It's the most simplified, watered down version of our function. So it's going to be log base 2 of x, set it equal to y. And now let's do that loop-de-loop and rewrite it as an exponential function. So it's 2 to the y equals x. Remember the loop-de-loop, 2 to the y equals x. Remember your exponent's always by itself over here on the right. Okay, so 2 to the y equals the x coordinate. Notice before, when we were doing an exponential function, we pre-populated the x values with 1, 0, and negative 1. This is the inverse, so we're going to pre-populate the y values with 1, 0, and negative 1. And we're going to plug in each of these values in for y in this equation right here to find our x. So it'll be 2 to the 1, 2 to the 0, and 2 to the negative 1. So 2 to the 1 is 2, 2 to the 0 is 1, and 2 to the negative 1, remember what that does. This is really 2 over 1. So when you have a negative exponent, you simply flip the number. So if this was 2 to the negative 1 over 1, we're going to flip that number and it simply becomes 1 over 2. When we flip it, the exponent becomes positive. So this becomes a positive 1 or just simply 1/2. Okay, so let's look at our points. We're going to not use this column right now. We're going to save that for later. We're almost done, except for the fact that, do you remember we have to do a vertical stretch by 3? And any number or sign in front of the log requires that we multiply. So we need to do that first. And that's what these extra columns for, in case we have to multiply by our x values or multiply by our y values. So in this case, I have to, with this vertical stretch by 3, I have to multiply my y values by 3. So 1 times 3 is 3. 0 times 3 is still 0. And negative 1 times 3 is negative 3. I can't use this point down here because the x value is a fraction and we can only graph whole number points. So the 2 points I'm going to graph are 2, 3 and 1, 0. So let's go ahead and do that in DeltaMath. So again, my DeltaMath screen looks a little different because I'm going in as a teacher, so bear with me. But once I get to this screen, I'm going to see the same equation that you see. So I click on question 1 and I see the exact same equation that we just looked at. F of x equals 3 log base 2 of x. First thing we need to do is select our asymptote. Remember that for logs, our asymptotes are going to be vertical, not horizontal. And as soon as I click vertical, all of a sudden an asymptote appears as well as my function graph. I'm going to graph the vertical asymptote first because guess what? It's very easy to forget that. So you want to do it first, and you should see a dashed line that fits right on top of the y-axis because x equals 0. The next thing we have to do is graph our points. We have the point 2, so if we find 2 on the x-axis, 3 on the y-axis, and the other point we're responsible for graphing is 1, 0. So, I don't even have to move the graph. This is 1 on the x-axis, 0 on the y-axis. So notice my graph gets incredibly close to the asymptote, but it never actually crosses or touches it, even though it looks like it does. If I blew up this graph, you would see that there's the ever so slight space between the asymptote and the graph itself. So let's go ahead and submit our answer. Yes. Okay, good. Now, hopefully, I'm going to go back out here for a moment so I can select the next point. And I notice I have 1 attempt here. Let me quickly change that to 2 attempts. Let's give everybody 2 attempts for each of these problems. Sometimes it's a little tricky to do these problems, so we want to give everybody a second chance, especially when you're learning something new. So let's go ahead and fix this. Give everybody 2 attempts. Last least. Oh, there we go. 2 attempts. Okay, so let's go back up now to question number 2. And let's go back to our graph. Before we graph it, let's go ahead and write down the important pieces of information that we need. So this equation is f of x equals negative log base 5 of x plus 7. So let's talk about the translations that are going on here. We have a negative sign in front of the log, so we're going to reflect over the x-axis. And then in parentheses, you have x plus 7, so you're shifting the graph left or right. It's a plus 7, so you're moving the graph left 7 units or 7 squares. And then last but not least, we have to find the asymptote. So notice the formula that we talked about earlier. We're going to take what's in parentheses, the x plus 7, set that equal to 0 and solve for x. And when we do, we get the fact that x equals a negative 7. So subtract 7 from both sides, and you get x equals a negative 7. So that's our new asymptote. Over here, let's look at the parent function. Remember, that's the minimalist version of this equation. So it's going to be log base 5 of x. It's just log base 5 of x. Set it equal to y. We're replacing f of x with y. And again, let's do the loop-de-loop to rewrite it as an exponential. It'll be 5 to the power of y equals x. So 5 to the power of y equals x. We already have the y values pre-populated with 1, 0, and negative 1. So we simply, to find our x coordinates, we're going to raise 5 to the power of 1 and get 5. 5 to the power of 0 and get 1. Remember, anything raised to the 0 power is 1. And 5 to the negative 1, that's going to give us, remember what we said, we can write 5 as 5 over 1 and flip the fraction or take the reciprocal, and that will give us 1 over 5. Now, remember what we have to do. We have to reflect over the x-axis. We have a negative sign out here. You can think of this as a negative 1. So we have to multiply all of our y values by negative 1. So 1 times negative 1 becomes negative 1. 0 times negative 1 is 0. And negative 1 times a negative 1 gives us a positive 1. So these are our new y values. So we don't need these values. We can go ahead and draw a line through them so we don't get confused. This is our new y column. So the points that we're going to graph will be 5, negative 1, 1, 0, and we're not going to use this point because it's got a fraction for the x value, and we only graph whole number points. Okay, so when we graph, we've already got the values that show that they're reflected over the x-axis, but we'll still have to move each of these left 7. So the x coordinates will change. We'll have to move each of the x coordinates to the left 7. So let's go ahead and graph. Remember, the first thing that we do, we select our asymptote. It will always be a vertical asymptote. And we're going to move the dashed line over to negative 7 to reflect that vertical asymptote. Try to be as accurate as possible. And then we're going to have to find the point 5, negative 1. So let's just grab one of the yellow dots, click on it, and I'm going to go over to 5 on the x-axis, and negative, come down here to -1 on the y-axis. We would be done, except we have to translate the graph left 7 units. So go count over 7 squares, 1, 2, 3, 4, 5, 6, 7 squares to the left. And we need to do the same with the other point. The other point is 1, 0. So that's already graphed for us, 1 on the x-axis, 0 on the y-axis, but I still have to move this point left 7 squares. So I'm going to go over 1, 2, 3, 4, 5, 6, 7. And DeltaMath is kind enough to draw the line for us. So I think we're in good shape. We look like it's fairly accurate. Let's submit our answer. Hopefully we are correct. If not, we have a second try. So it's not a big deal. Good. We're okay. Okay, let's go back out to number 3. And so this function's a little bit more complicated. It's 2 times the log base 5 of x plus 3 plus, x plus 2 in parentheses plus 3. So what does all this mean? So let's go through the translations. So the first thing we're going to do is we've got a vertical stretch by 2. So that's what that 2 signifies. It's going to be a vertical stretch by 2. And then we have x plus 2 in parentheses. That means that we're shifting the graph left or right because we're adding a 2 to x. So we're going to shift the graph left 2. And then outside the parentheses is, sorry, this is what you get. My alarm. Outside of the parentheses, we have this plus 3. That shifts the graph up or down, so that's going to change the log function. So in this case, because it's plus 3, we're going to go up 3. So let's go ahead and find our vertical asymptote. Remember, we're going to just forget about the 3 on the outside. We're just going to take the x plus 2 and whatever's in parentheses, and we're going to go ahead and set that equal to 0. So if you set x plus 2 equals 0, you subtract 2 from both sides and you get x equals -2. Now, last but not least, let's figure out what the parent log is. Now, remember what we said, the parent log is the simplest version of this equation. So we're just going to take the word log, the base 5, and x. So it'll be log base 5 of x. Set it equal, instead of using f of x for graphing purposes, let's go ahead and use y. So it's going to be, and then we're going to rewrite it as an exponential function. So it's going to be 5 to the y equals x. So 5 to the y equals x. All right, so let's go ahead and do that. So remember, our y values are pre-populated with 1, 0, and -1. So it'll be 5 to the power of 1 is 5, 5 to the 0 is 1, and 5 to the -1 is 1/5. Or you could have copied them from the graph above. That would have been just as easy to do too. Okay, let's look. Remember, we're doing a vertical stretch by 2. So we have to multiply all our y values by 2. So let's go ahead and do that. So 1 times 2 is 2, 0 times 2 is 0, and -1 times 2 is going to be a -2. So our new values are going to be 5, 2, 1, 0, and we don't have to graph this point because the x value is a fraction. Okay, let's not forget, while we have gone ahead and translated the graph through the vertical stretch, we still have to move each of these points left 2 and up 3. So let's go ahead and do that. Here's our graph. Remember that every asymptote is going to be a vertical asymptote for a log, and we're going to go ahead and quickly graph that so we don't forget to move that dashed line to x equals -2. So just move it over here to x equals -2. And then our next step is to graph each of these points. So let's go ahead and click on one of these yellow dots. I'm going to drag it over to x equals 5, and then I'm going to go up to the 2 on the y-axis. So this is the point 5, 2. I still have to go left 2, 1, 2 squares, and I have to go up 1, 2, 3 squares. So there, I'm done with that point. Let's do the next point. The next point is 1, 0. It's already graphed for me. However, I still need to move this point left 2 squares and up 1, 2, 3 squares to the new point. So if you're going left or right or up or down, you are going to have to translate the points you get from the table. So here's the graph. I feel good about this. Let's see if we did it right. And again, if we didn't, we have a second chance. It's not a big deal. Okay, good. We got lucky. Okay, let's go out to the next question. All right. So we're getting more and more complicated, but I think it helps to look at difficult problems, and then it'll make graphing a little bit more easier for you when you have to do it on your own. So this is log base 4 of negative x plus 1 in parentheses minus 8. So what's going on here? So first thing I'm going to do is actually rewrite this equation. So remember that when you have a negative sign in front of it, the x, that's a reflection. And it's a little confusing to look at. So we need to go back and say, okay, what's actually happening with x plus 1 here if we're putting a negative sign in front of x? So I'm going to use the distributive property of reverse or pull out the negative sign. When I do that, that changes the sign of everything that comes behind that negative 1 or negative sign. So when I pull out the negative sign in parentheses, I'm going to make this a positive x and a negative 1. So look at what I'm doing. I'm pulling out the negative sign, and in parentheses, I'm just changing the sign of everything that you see. This was negative x. It's going to be a positive x. This is a positive 1, and it becomes a negative 1. So you're using the distributive property in reverse to factor out a negative 1. So my equation is really f of x equals log base 4 of negative, in parentheses, x minus 1 minus 8. So what are we doing here? When you have a negative sign in front of x, you're going to reflect over the y-axis instead of the x-axis. What else are we doing? I've got an x minus 1, which means I'm moving the graph to the right 1 unit or 1 square, and then negative 8 means I'm also shifting the graph down 8. So to find the asymptote, remember I'm going to take the equation x minus 1, I'll set it equal to 0, add 1 to both sides, not subtract. This time we're adding 1 to both sides, and I'm going to get the vertical asymptote x equals 1. Now remember, we need to write the parent log, which is the most basic or minimalist form of this equation. So it's just going to be log base 4 of x equal to y instead of f of x. And then let's go ahead and rewrite that in exponential form. So it's going to be 4 to the power of y equals x. 4 to the power of y equals x. All right, our y values are pre-populated with 1, 0, negative 1. So we're going to raise 4 to the power of 1 and get 4, 4 to the 0 and get 1, 4 to the negative 1 and get 1/4. Now, we're reflecting over the y-axis. So that means we have to multiply negative 1 by all of our x values this time. So we're going to multiply 4 by negative 1 and get negative 4. We're going to multiply 1 by negative 1 and get a negative 1. And then we're going to multiply 1/4 by negative 1 and get a negative 1/4. So we're just changing the sign of all of these values. We don't have to graph this last coordinate because it's a fraction. So let's write down the points for all the others. 4, 1, or yeah, I'm sorry, I'm going to the this x column. I don't need to go to this column, and in fact you might want to draw a dashed line through it or a line through it just so you don't get confused. The points that we're going to graph are negative 4, 1, and negative 1, 0. And again, let's not forget these values represent a reflection over the y-axis for this graph. We'll still have to move each of those points to the right 1 and down 8. Okay, so let's try this. So we have a vertical asymptote that at x equals 1. So I'm going to drag the dashed line all the way over to x equals 1. There we go. I think that looks good. Notice that I'm right on the dot or point for one of the pre-populated points. So my graph has disappeared. It'll reappear as soon as I move this yellow dot off of the asymptote. All right, so let's graph the first point. Negative 4, 1. So we have -4 on the x-axis and 1 on the y-axis. Now, again, we're not done. Don't stop there. We still have to go to the right one. And we have to go down 8. So I have to count down 8 squares. 1, 2, 3, 4, 5, 6, 7, 8. Here we go. We're going to stop right here. And let's do the other point. The other point is -1 on the x-axis and 0 on the y-axis. And then we still have to go to the right one, which puts us directly on the y-axis. And we have to go down 8. So let's count down 8 squares. 1, 2, 3, 4, 5, 6, 7, 8. So we're actually on the point 0. 0 on the y-axis, -8. I'm sorry, 0 on the x-axis, -8 on the y-axis. And let's go ahead and click and see if we did it right. It's okay if we didn't. We have a second shot. Good. We got lucky. Okay. Let's move on to graph number 5. And again, let's take a moment, see if we can focus this a little bit better. It looks like it's gotten a little bit blurry. Okay, there, good. Okay, we have f of x equals -3 log base 4 of, in parentheses, x minus 2 plus 3. So we don't have a negative sign in front of the x, so we don't have to worry about a reflection over the x-axis. So this is nice. It's straightforward. We're just going to take the function as is. So let's read it from left to right. That's the easiest way to identify all the translations. So we have a negative sign up front. That means we're going to reflect the graph over the x-axis. And then we have a 3. So that's going to be a vertical stretch by 3. Then in parentheses, we have x minus 2, which means we're shifting the graph to the right 2 units. So remember, if the number is in parentheses with the x value, you're shifting the graph left or right. The plus 3 is outside of the parentheses, so that means you're shifting the whole log function up or down. In this case, it's positive, so we're moving the graph up 3. Let's take what's in parentheses, x minus 2, and set it equal to 0. We're going to add 2 to both sides and get x equals 2 for our vertical asymptote. Now, let's write down the parent function. Remember, that's going to be the word log, the base, and x equal to y. So it's just going to be log base 4 of x equals y. Let's rewrite that in exponential form so we can graph it. So it'd be 4 to the y equals x. 4 to the y equals x. So our y values are pre-populated as 1, 0, and -1. 4 to the power of 1 is 4. 4 to the 0 is 1. And 4 to the -1 is 1/4. Okay, so we have our 3 values there. Now, we have to reflect over the x-axis, which means we have to multiply all the y values by -1, and we have to vertically stretch them by 3, so we have to multiply them by 3. So let's do that at the same time by multiplying all of our y values by -3. So 1 times -3 is -3, 0 times -3 is 0, and -1 times a -3 will be a +3. So we have to graph 2 points. So we're going to graph 4, -3, and 1, 0. Now, keep in mind here, we're not going to graph this last point because it is a fraction and we only graph whole number coordinates. So we're going to graph each of these coordinates, but then we're not done. We'll still have to translate them. We'll have to move each point to the right 2 and up 3. So let's go ahead and do that. So remember, our asymptote is going to be vertical. All right. Let's move the dashed line over to x equals 2. I really think you need to do that first because it's so easy to forget if you don't do it after graphing the 2 points. Okay, so we have the dashed line at x equals 2. Let's graph the first point. It's 4 on the x-axis and -3 on the y-axis. Okay. Almost done, except we have to move this point to the right 2 squares. And then we also have to move it up 3. So we're going to go up 1, 2, 3. Very good. And now let's go to the next point. The next point is 1 on the x-axis, 0 on the y-axis, so it's already in the right place for us. We're going to move it to the right to 1, 2 squares, and we're going to move it up 3. So we're going to move it up 1, 2, 3. So there we go. I think we're in good shape. Let's go ahead and click submit and see if we got the right answer. If not, we can try again. Yay! Okay, good. All right, last but not least, one more problem. And this one was one of the most difficult ones I could find. So I figure if we can graph this, we can graph anything. And if we make a mistake, again, we have to attempt, so it's okay. Okay, so let's talk about this. Notice that when I look at this equation, there's a negative sign in front of the x. So the first thing I'm going to have to do is rewrite what's in parentheses. So it's going to be f of x equals -2 log base 2 of, let's take out that negative sign. So we're going to use the distributive property in reverse or go backwards, pull out the -1, and in parentheses, we're going to change the sign of everything we see. So it'll be x plus 6. So we're simply changing a negative x to a positive x and a -6 to a positive 6 because we have the negative sign factored out. And then out beyond the parentheses, we're just going to put a -5. So we copy down the -5 out as is since it's outside the parentheses. So now that we have the function rewritten, let's go ahead and identify everything that we need to do. So I always read it from left to right. So first thing we encounter is this negative sign. That means we're going to reflect over the x-axis. Then you have a 2 in front of the word log. That means that we have a vertical stretch by 2. Then we encounter the negative sign. So that means we're going to reflect over the y-axis. And then we have x plus 6 here. That means that we're going to shift the graph left 6 units or 6 squares, and then a -5, which means we're going to shift the graph down 5 units or 5 squares. Let's take what's in parentheses, forget about the negative sign. We're just going to take x plus 6, set it equal to 0, solve for x by subtracting 6 from both sides, and we'll get x equals -6. That will be our vertical asymptote. Okay? So now let's go ahead and graph this function. So remember, we're going to start off with the parent function is the most basic watered down version of this equation. So it'll be log base 2 of x equal to y. So log base 2 of x equal to y. Let's rewrite it as an exponent. Do your loop-de-loop. 2 to the power of y equals x. So 2, remember your y values, they're going to be 1, 0, and -1. We're going to plug them into this equation. So 2 to the power of 1 is 2. 2 to the 0 is 1. And 2 to the -1 is 1/2. Now, we've got to do a couple things here. Since we're reflecting over the y-axis, we have to multiply all of our x values by -1. So we're going to do that. So this will be 2 times -1 is -2. 1 times -1 is -1. And 1/2 times -1 is -1/2. Now, we also said we're going to reflect over the x-axis. So that means we have to multiply the y values by -1. And we're going to do a vertical stretch by 2. So we need to multiply our y values by 2 as well. So let's do that at the same time by multiplying each of our y values by a -2. So 1 times -2 is -2. 0 times -2 is just 0. And -1 times a -2 is going to be a +2. So the points that we graph will be -2, -2, -1, 0, and we don't have to graph this last point because the x value is a fraction and we can only graph whole number coordinates. So we've taken care of our reflections and our vertical stretch. However, after we graph each of these points, we're still going to have to go left 6, down 5. So let's do that together. So again, the vertical asymptote, not a horizontal asymptote. So vertical asymptote, because it's a logarithmic function, we're going to drag the dashed line over to x equals -6. All right. And then let's graph the first point. It's -2, -2. So let's find -2 on the x-axis. and -2 on the y-axis. All right, and then we're not done. We have to go to the left 6, so let's go ahead and shift 1, 2, 3, 4, 5, 6, and down 5. 1, 2, 3, 4, 5. Hopefully I counted right. I'm a little nervous I'm off by 1. Now notice the line has disappeared. So the line will reappear. Remember, you cannot cross a vertical asymptote or horizontal asymptote. So the line has disappeared. When I move the yellow point over to the same side of the asymptote as the other yellow point, then that line will reappear. Okay, so we're graphing the point -1, 0. So -1 on the x-axis, 0 on the y-axis. And then we have to move it to the left 6 units. So 1, 2, 3, 4, 5, 6. You notice our line has now reappeared. And we're going to go down 5. So 1, 2, 3, 4, 5. All right, so here we go. And hopefully we did it right. If we didn't, it's okay. We have a second chance. So let's check. I might be off by one of my dots. I feel like, oh, great. So, all right, we are done. Did a good job. Thank you for graphing with me.